Good morning to everyone who just joined us here at the demo event. Thanks so much for joining us. Get comfortable because we're very happy to show you an exciting program this morning. We thank you very much for joining us, and I'm going to introduce the event and just a few housekeeping issues. So please just pop yourself on mute while you're joining us here this morning. Please be aware that the meeting is recorded today. So if you wish to not be recorded, please turn your camera off. That's no problems for us. We're very excited to be able to share this event in the future through the recording. So welcome everyone to the African Catfish in SmartRAS iFishIENCi Virtual Demo event. My name is Danny O'Brien, and I'm going to be supporting the team today so you can have the best possible experience with our event. Be aware that the meeting will be recorded. There will be lots of information presented today by our experts, and we welcome any questions you might have. So please type your questions into the chat box during the sessions, and we'll make sure those questions are read out during the Q&A session. You'll be first in line. If you have other questions then during the interview period, you can use the reactions button to raise your hand, and we'll call on you to ask a question of our experts. So thank you so much for joining us. I'd like to now welcome the coordinator of iFishIENCi, Mr. Tamas Bardos, and he's going to open the demo for us today. So welcome and enjoy.
Hello everyone, and I would like to welcome you on our first virtual demo event in the iFishIENCi 2020 project. iFishIENCi is a project which is implemented in a consortium of 16 partners from all over of Europe, including small and medium enterprises, academic organizations, and aquaculture industry organizations as well. Together with some other projects in the Horizon 2020 program, we are working on innovations which can modernize the aquaculture industry in Europe and in the whole world, and can bring in new technologies to achieve the so-called aquaculture 4.0 version of the aquaculture industry. The main goal of our iFishIENCi Innovation Action Project was to bring already existing scientific knowledge into an innovation level where these innovations can be taken by the industry. And in our project, our focus was on the digitalization and how the improved use of the most up-to-date IT technologies can support the feeding technologies, genetic innovations, and application of new feed ingredients in the aquaculture. The project is approaching its end. We will complete our project in next July. And we are at the moment we are finalizing on innovations and product, and we will mention some of this product today. But the four product of the projects are the so-called Fish Talk to Me product, which is a series of new type of sensors, where we investigate how these sensors, what new information these sensors can provide for the aquaculture industry, and how this new information can be used by the industry. And this is supported by our other product, which is called iBoss, which is basically a kind of decision support system based on a web on an online cloud platform, which is collecting all the information from the new and existing sensors of the aquaculture industry, and will provide a kind of improved use of all this data. Will provide new algorithms for the farmers to analyze better the data. And all these new innovations will be used in our so-called SmartRAS product, which is a new generation. We plan this will be a new generation of the recirculating aquaculture systems, where we use the iBoss and the new sensors to improve three main areas of the recirculation technology, and these are the water treatment technology, the feeding technology in RAS systems, and we also want to achieve an improved use of the existing sensors what we have already in the recirculating system. And our fourth product, which is which we will talk mainly today as well, is the waste to value product, where we investigate how new feed ingredients can be used in the aquaculture industries, which feed ingredients can be produced by using the waste streams of other industries. But we also investigated how aquaculture waste streams can be used to produce new feed ingredients. So this online demo event is a series of demonstration activities, what we had before, and we will have in the next few months. And it's very important for us to show what we achieved and what we are working on still in the project to facilitate the uptake of these new innovations by the industry. And today we will focus on the achievements in terms of African catfish breeding and new feed testing, which was carried out in a SmartRAS system in the AquaBioTech, as you will see. Above this, we will have many other product of the project and achievements of the project, what we would like to demonstrate in the next few months. So I suggest you to subscribe to our Twitter and LinkedIn account, which will be put in the chat of this meeting as well. And there you can follow the new publications and upcoming dissemination event of the company, of the project. But please use this event today to have your questions related to the recent innovations in the African catfish breeding and feeding, and enjoy the event. And I would like to give the floor to our leading scientist on this field, one of our leading scientists on this field, Dr. Gianmarco Cosimano, who will give you an introduction of the experiments what we did in AquaBioTech together with our partners from Hungary and Norway. Gianmarco, the floor is yours.
Thank you, Thomas, for the introduction, and hello everyone. Good morning, and thanks for joining us in this video virtual demonstration tour. So, as Thomas said, I'm Dr. Giovanni Marco Cosimano. I work in AquaBioTech as a RDI research coordinator, and I'm in charge of the African catfish experiment. So, first of all, I would like to give you some information about our company. AquaBioTech Group is an international consulting company that undertakes a variety of aquaculture, fisheries, and aquatic environmental projects within its department. In one of the departments, Innovia, we offer research service to support the development of vaccine, functional feed, novel protein source in a fully licensed and biosecure R&D facility. In one of the systems, named Bay0, we are conducting the experiment with the African catfish, with a new breed of African catfish in a SmartRAS system. Why we choose African catfish? First, because we know that African catfish is one of the developing species for aquaculture. It has a very fast growth rate. Can be fed on a variety of agricultural byproduct because it's an omnivorous species, and it's highly tolerant to adverse water quality and environmental conditions. African catfish is well developed in Africa, Europe, like Belgium, Hungary, and Netherlands, and South America. So we know that in most of the country, the consumer's acceptance is highly developed for the fillet of this fish, and it's an affordable source of high quality protein of food that it's perfect for an increasing global population. Saying that, I would like to introduce you to the virtual site tour. So we're going to play a video of about 5 minutes in which we're going to give some information about the African catfish experiment. We're going to show you the system where the African catfish experiment is ongoing. And at the end of which we're going to interview some experts of the project. because as Thomas said before, the project has been in partnership with 16 different partners, and we are gonna share with them the results of the project. So I will leave now to the video, and we are gonna come back later for the interview with the expert and Q&A panel. Thank you.
iFishIENCi Horizon 2020 EU project brings together 16 transdisciplinary partners for genuine improvement to the aquaculture management practices using Aquaculture 4.0 innovations. We are now demonstrating in operational environments the testing phase for the developed technologies. One of the current experiments is being carried out at our partner AquaBioTech Group, who specialise in aquaculture research in closed recirculation systems in their Innovia research facility. In one of their trial rooms, called Bay 0, the research examines to what extent varying inclusion levels of Candida meal affects growth and feed utilisation performance in a specially selected hybrid of African catfish when produced in SmartRAS over a 10-week period. And now to Dr. Cusimano with more details.
Hello everyone, I'm Dr. Giovanni Marco Cusimano and I work as RDI Research Coordinator here at AquaBioTech Group. Today I'm going to talk to you about the latest progress of our iFishIENCi project. The SmartRAS system includes 12 fiberglass tank of 650 liters with recirculated fresh water using a full RAS system that includes a drum filter, biofilter, protein skimmer, UV and ozone disinfection. All major water quality parameters such as pH, temperature, oxygen and redox potential are continuously monitored in the SmartRAS system to ensure a stable environment for the experimental fish. Fingerlings of hybrid catfish were supplied by our project partner from Hungary, named Mate, at a size of 0.5 grams and stocked in a quarantine system for 2 weeks. They were then reared up to target size of 70 grams and then acclimatized in the experimental system for at least 1 week prior to the start of the trial. Specially bred catfish are fed with novel feed formulations 3 times a day to satiation by hand. A controlled diet and 2 test diets with 10 and 20% of Candida meal inclusion were formulated to be isonitrogenous, isolipidic and isoenergetic and tested in triplicate. The Candida meal was produced by NORCE as part of another research being undertaken in the project. Daily routine activities included general husbandry, mortality collection if any, behavioral observation and water quality monitoring and testing. Specific requirements such as dissolved oxygen level, temperature range for optimum growth, pH and others were listed in the trial specification as follows. Dissolved oxygen level above 6 mg per liter, temperature range 27 degree plus minus 1.5 degree, light regime 12 hours light, 12 hours dark. Regular cleaning and disinfection of equipment are performed following the high standard biosecurity of the SmartRAS facility. Water quality tests are measured daily: temperature, oxygen, pH, ammonia, salinity, nitrite, nitrate and alkalinity. Fish were weighed in bulk at the start of the trial after 4 weeks, and they will be weighed again at the end of the trial to evaluate the growth. The performance indexes FCR, SGR, PR, SFR will be calculated and compared among the experimental diets to evaluate the potential use of Candida meal as a novel protein source. Additional sampling such as histology of liver and intestine, brain, gills, muscle and skin, fillet for color assessment, sample of water and sludge to evaluate the microbial community of the system, and a potential variation among the test diets, as well as sample of feed for proximate composition, total protein content, lipid, ash, fiber, amino acid profile, and fatty acid profile, were collected and analyzed either in-house or sent to a project partner to evaluate the potential application of Candida meal in catfish feed formulation. Thank you for your attention, and thanks to all the partners involved in the project.
Welcome back, everyone. Hope you enjoyed the video, and apologies for who could not see the video. As Danny said in the chat, we're gonna share the video shortly with you. I hope that all the other people, they watch the video. So first of all, I would like to give you some more information about the trial. Currently, we are on the last 2 weeks of the experiment, and we're gonna finish on next week. For the last sampling, our partner NORCE is going to join us, and we're going to collect samples about histology, and we're going to conduct some stress-story challenge to analyze the cortisol level in the fish. For another partner named Leitat, our Spanish partner, we're going to collect a sample of sludge and intestine to analyze the microbial community of the fish, and to evaluate some difference among the three treatments. Also, as an internal part of the sampling, we're going to conduct analysis on fillet coloration, proximate composition of the fillet, and histology to evaluate morphology and general status of the intestine, as well as status of the liver, vaporization of the hepatocytes, morphology of the hepatocyte, and an eventual steatosis of the liver. Of course, all these results will be shared in scientific conference and in a published review article. So I hope you will subscribe our LinkedIn and Twitter page. We're going to post some of the results of the trial. Also, I would like to tell you that from the preliminary results, there are some interesting aspects of the trial. So we hope that by beginning of January, or say a few weeks later, we can start sharing our results. Now, I would like to introduce a panel of experts of the project that will be addressed with some questions. And as soon as we finish with the interview, we're going to leave the floor for some Q&A panel. So first of all, I would like to introduce again our project coordinator, Tamas Bardos. And I will ask Tamas some questions regarding the project. First of all, I would like to say that today we mentioned that we are implementing our catfish experiment in a SmartRAS system, which is an innovation of the iFishIENCi project. This is not the main focus of the demonstration today, but because we have here Tamas, that is also the responsible of the development of this product in the consortium, I would like to ask him about the SmartRAS system. What is exactly, as a product of the iFishIENCi project, the SmartRAS system?
Yes, thank you, Gianmarco, for the question. Yeah, as you could see in this video as well, beside of the experiments with the feeding and the different feeds in the catfish, we also did some work on the SmartRAS development. As you could see in the video, we had some cameras above the tanks, and we also had feeding robots on the tanks, and also we had a specific waste collecting system, which is called swirl separators, which are known in the RAS industry, but not used everywhere. And what we did during the catfish experiments to develop the SmartRAS, that we tested different elements in parallel with the feeding experiments. So, for example, we tested the cameras, what are the best angle, best height of the cameras to take video footages about the fish in the water where the transparency is lower, and how can we use these videos to identify typical fish behavior in the future. We also collected the water quality data from the sensors of the RAS system, and we tested how can this data can be pushed into the iBOS platform, where we can do further analysis of this large amount of data. In most of the recirculating systems, we collect all this data, oxygen level, pH, temperature, a lot of data are collected, but they are not used for further analysis and develop algorithms based on this data. And this is what we will do in the iFishIENCi and in the iBOS system. And we also tested how can the feeding robots connected to the iBOS system, and how can the iBOS system control the feeding robots in the future. And all this data will be, and all this information and the outcomes will be incorporated in the next experiments, next demonstration trials, where we will test these things. How can we control the feeding robots to the behavioral detection of the cameras, and we will demonstrate. We will show this for the public as well, maybe in next March or April or next demonstration event. So all these things will be incorporated in a new design of the recirculating system, what AquaBioTech is doing. And we think that this new design will help to reduce the operational costs of the recirculating system. We reduce the energy use as well, but most importantly, we reduce the feed cost and environmental impacts of the system, because we can reduce the feed loss in the system. So this is shortly the summary of this product.
Thanks, Thomas, for the answer. I want to mention that the SmartRAS system has been implemented in our facility, where it was already the monitoring controller of the water quality, and the system it was already in place 24/7. So we are using the data provided by our system to implement the iBOS and Cobalt system. So it's already in a good stage. So now I would like to give the floor to our two experts from Mate University. It's a Hungarian university, and they are in charge of the breeding and genetic selection of the African catfish. So I would like to introduce our colleague, Dr. Juliana and Babas. And I would like to ask them a few questions about the African catfish. So first of all, I would like to ask them why to breed and select African catfish.
Okay. Hello, everyone. So the question is very simple, because African catfish is a very good target for the RAS system growing. It has a very fast growing and it's feed everything. So it's an omnivorous fish, tolerate the different wide environmental conditions and the water quality, and we can use it in RAS system very efficiently with high density, high amount of fish in 1 cubic meter. On the other hand, the FCR is very good, so, and it's below 1, which is much better than in most of the fish. The meat quality is good, and it's the meat is not contains bones, so it's only a few one. But there is some limitation of the using of this fish because it has the temperature sensitivity. So below 19 Celsius, it's not produced well and not survive below 14 Celsius. So good for us because the protection of our environment. On the other hand, the largest cost of the production is the feed. It's more than 50% of the cost is the feed production, feed consumption, and we can use a very high protein content in these feeds, and it is very expensive. And if we would like to reduce the fish, the animal originated protein by using soya meal, the production is decreasing in case of most of fish species like Nila tilapia, sea bream, Atlantic salmon, and others. And it's also true for African catfish. So that's why we started this selection program for this African catfish, which is very good for in production in the RAS systems. The
Thanks,
African
Balázs,
cat.
Thanks, Balázs, for the answer. I would like to ask you about how was the hybrid catfish produced? Because we know that, so in the video we introduced the species as an African catfish, but we know that the species that we are reading in this experiment is not a pure line of African catfish, it's an hybrid line. We know there might be different breeding of the catfish, and I would like to ask you, how was the hybrid catfish produced, and which species do you use to, let's say, to breed them?
In the practice, the Hungarian breeders are using two species. One is the African catfish, the Clarias gariapinus. The other one is the Heterobranchus longiphilis, which is also originated from Africa. And the hybrid of these two fish is more widely used than the poor line of African catfish because the hybrid can survive more after the propagation, so the survival rate is higher in RAS systems, and these fish are produced by crossing the African catfish female with the Heterobranchus longiphilis males, and the hybrid contains 50% of the genome from one side and from the other side also, so it's a third generation hybrid. And the meat quality of the hybrid is a little bit different. The meat is lighter, and the rate and the survival rate is cannibalism rate is lower and the survival rate is higher during the production after the first period, and I don't know, maybe it's the meat quality is the other thing which is also important because the consumers I like it better. Can you hear me?
Yes, okay.
Okay.
So thanks for the answer. I have another question about, So we already talked about, let's say, how was the hybrid catfish produced, or which species were used to breed them. But what's the advantage of having a hybrid instead of pure line? We already discussed about the meat acceptance from the, let's say, from the consumers. Is there any, let's say, growth advantage on the?
Yes. Yes, the growth rate of the African, the hybrid is higher than the pure line. It is because the maturation time of the hybrid is much later, longer, and the fish can use the energy for the growing, not for the maturation and the oocyte or the sperm production. So, and it is why the hybrid has a much efficient growing rate.
Okay, we know that in some species, the sex is one of the issue of the farmers, because if there are more female than male, female will use most of the energy to maturate the gametes, and then the size is smaller than the male. So in this case, we don't have this problem. I mean, we are testing the species at the moment. We are testing the 2 genetic line in one parallel experiment. So we're going to analyze this data, because just for the people that are here, the main experiment of the African catfish was to test the inclusion of the Candida meal in the diet. But we have a parallel experiment where we are testing the selected and non-selected line of the breeding program to see if there are differences in growth and feed utilization. Also, that will be compared with the same experiment that has been conducted in Hungary in a flow system. So we want to show if there are differences also in a RAS system. Okay, thanks, Balázs. And I have the last question about, was the genetic line that we are using for the experiment selected for nutrient utilization or for growth, or maybe for both?
Okay. The hybrid itself was not selected, but one of the parental line, the African catfish, was selected for the grow and for the better utilization of low fish meal containing feed. The fish meal was instead of fish meal, that was used some algae meal to adding protein to the feed, and we used this feed as a selection. And in this way, this line, the maternal line of the hybrid, was selected not just for growth rate, but for the lower fish meal containing feeds also. We selected in this fish through 3 generations, and approximately 7 to 8% of fish was used selected for the next broodstocks in every time.
Okay, thanks, Balázs, for to answer all the questions that I asked you. Just to add something about the fish meal content in our experiment with inclusion of Candida meal, we used very low fish meal content of about 5%. So we were testing also the feed utilization in a low fish meal diet. So now I would like to give the floor to our expert from NORCE. NORCE is a partner of the project that was in charge for the production of the yeast, so the Candida meal, and also of the algae meal that Balázs mentioned before, because one of the product of the iFishIENCi project was also the Microchloropsis garitana, that it was used as a novel protein source and also source of fatty acid in the project. In this case, for the experiment of the African catfish in AquaBioTech, we instead used the Candida meal for the feed formulation. So I will give the floor to our colleague Catherine from NORCE, and I will ask her 2 questions about the Candida production and utilization. welcome, Catherine. Thanks for joining us.
Hello.
And I will ask you two questions about the Candida production. The first one is why Candida yeast has been selected for this project?
Okay, so yeast in general have been shown to be a very good potential replacement feed ingredient in aquaculture feed. The reason for this is its high protein content is typically above 50%, and then typically also a very good composition in amino acids and B vitamins. The Candida we chose here, the Candida utilis, is one of the high protein contents of 55%, and contains lysine, threonine, a range of amino acids that's very good. So it's as a starting point a really good single cell protein. Single cell protein because when it is produced, it can actually be dried. The entire biomass can be dried and used as such because of the high protein content. It makes processing quite easy and production on industrial scale also quite easy.
Thanks, Catherine, for the answer. I want to mention that when we formulate the feed for our experiment, it was quite easy to formulate the feed even with 20% of inclusion because, as Catherine said, the amino acid profile and the composition of Candida was very close to the, say, principal raw material that we use for say, in aquaculture as a protein source. Now, I want to ask you about the production of the Candida meal. So how is it produced?
Okay, so yeah, as I said, it's quite easy to produce, and there's little processing. So at NORCE, what we do is because it's a live microorganism. An interesting thing about it is it can be fed actually with quite a wide range of feedstocks, and it means that potentially it could use waste compounds, byproducts, and the like. In this project, we used sucrose and just to have a sort of standardized production. So the yeast was first grown in small batches, 2-liter flasks. They're grown overnight. They grow at 30 degrees using oxygen. It's quite an easy growth. So basically an overnight growth, and then that can be used as an inoculum to move onto a fermentation reactor, which is a bit more specialized. That moved to a 15-liter reactor in which we use 8-liter culture. So again, it's grown at 30 degrees and overnight, roughly, about 11 hours, fed sucrose. At that level, we monitor pH, pressure, agitation, so that the growth goes well and the quality is checked. And then that's used to inoculate a large reactor. So for this project, we used a reactor of 1,500 liters. This was used 3 times because I think overall over 100 kilos of dry matter was produced. But yeah, so we did three batches in the 1,500, and for that one, it's first inoculated in a half-filled reactor, and then it is fed. So that's left overnight, and then it is fed over another 11 hours or so until it reaches a biomass which we know is good. During the whole process, of course, everything is being monitored. This is still a research project, so it's very carefully monitored and adjusted. And then the entire biomass is then concentrated using a centrifuge, and then it is dried. And basically that's it. The entire biomass is dried and used. And in 800 liters produced, that produces about 35-40 kilos of dry powder, which can be used entirely as a protein replacement.
Thank you, Catherine. So following your answer, I would say that when we formulate the feed, because of the high feed demand of the catfish, we produce something like 400-500 kilograms of feed, and NORCE provide us 90 kilograms of Candida meal. So following your discussion, it was like a very good job to produce all this powder, and thanks for that. So now I would like to give the floor to my colleague Danny for the Q&A panel. So there will be question on the chat, and we will try to answer to all of them.
Hi, Gianmarco. We haven't got any questions yet in the chat, so I'd like to ask if anyone has any questions regarding African catfish, regarding the breeding program during the iFishIENCi, regarding feed that has low fish meal or fish utilizing low fish meal feeds. To please raise your hand. You can use the reaction button at the top of your Teams screen to put your hand up, and we'd love to welcome you. Or you can write a question into the chat box if you'd like to, and we can read it out for you. Do we have anyone who has any questions for any of our experts here today? Okay. Do we have any of our members of our team who'd like to make any concluding remarks? If you do think of any questions later on today, yes, we've got one here. We've got a question in the chat. What is the energy consumption? I think that's a question related to the feed utilization, or is it related to the running of the SmartRAS system?
I think it's about the RAS system.
Okay. So might be an energy efficiency question there. Do we?
So
yes.
I can answer this with this, yeah, running of RAS as well as feed production. What we are doing at the moment, and what we are working on at the moment, we also had a kind of electricity consumption measurement in the whole RAS system. So we will have data about the whole experiment on this. And also we are collecting data from our partners about the production of the feed ingredient, and all these elements will be used for a life cycle assessment analysis of the experiment on which my colleague is working on, and will be discussed there and published there. Because we are still in the experiments, I cannot give you an exact answer what is the energy consumption of the system as well, a system of where we work. But maybe Gianmarco can tell more about this.
Yeah, so following your discussion, we still don't have the final data about the consumption, but we will be also water consumption, because one of the aim of the project, as Thomas said, is to avoid any feed loss and also water, let's say, not used in a proper way. So what we're gonna do, we're gonna analyze together the data from the energy consumption, the water consumption, to let's say keep in mind that we have to have the best environment possible for this fish, even though we know that as a water quality requirement, these fish are not very sensitive. But in general, as a company, we try to keep our standard as high as possible for all the species that we manage. So at the end of the trial, we're gonna analyze all the data regarding the different aspects of the experiment, and this data will be shown in the project website or in the let's say in the final deliverable and report of the project.
Kate, please be welcome to give your answer.
Yes. So when it comes to the production of the Candida, of course, the way it's produced in an R&D project, it will be more energy consuming than produced in a big industrial setting. So we're looking at at what the consumption would be. There are also other aspects of sustainability that are looked into within this project. For example, one of them is looking into the use of the sludge from the aquaculture trials and looking into that as a feed ingredient for the Candida. So that's one of the circularity aspects, and the work is still ongoing actually, but the results are very promising, I'm glad to say.
Thank you very much. We have another question in the chat asking about the health monitoring conditions. So they ask, do you have any rapid tests in the facility to detect bacterial or viral diseases?
So I would like to answer to the question. So first of all, our health check is a daily monitoring about, we have a team of veterinary that perform health check. So whenever there is they suspect there is a bacterial infection or whatever, we conduct microbiology. We send sample for PCR. So, and also because of the nature of the RAS system, that it is independent from the other system, we can contain the spreading of the potential disease because of the high biosecurity standard of the facility. So as you could see in the video, we always use disinfection of the equipment, disinfection of the, let's say, person that is going to perform the check. So yeah, we don't have any, let's say, continuous health check like sensor that can detect bacteria in the water, because we know that the microbial population of our system, it's, let's say, difficult to monitor on all aspects. When we suspect something, we have specific tests to detect, say, any potential disease for the species in use, because we know that as a RAS facility, we can use different species. We have salmon, we have catfish, tilapia, sea bass, sea bream. So for each species, there are target pathogen that we can detect.
Thank you very much, Gianmarco. We have a question here regarding the two Clarias catfish species, hybrids, sorry. Is there any difference in the air breathing efficiency or frequency of the two hybrids? Has there been any comparison?
This one is a question that I can answer, something related to our experiment, because we have the two lines, the selected and non-selected, and so far we haven't seen any difference on them, but I think maybe Balázs can give us some more information.
My answer is the same. So we don't know anything which is different in case of the poor line and in case of the hybrid. So both fish are behavior in the same way. So no differences.
Thanks very much. Is that something you'll be looking at in the future, Balázs, regarding this air breathing efficiency? Is it something that you target in your research, or at the moment it's not an area of inquiry?
I don't think it's a target of our research because there is no problem with that. So it can utilize this fish. Both of the species can utilize the air oxygen, so they can come to the surface taking some air and they can use that. So there is no the water oxygen level is not important thing in this case.
Thank you. We have another question regarding sustainability and the circularity of the system. What about the CO2 production from the fish production? Is that being considered in the SmartRAS or under the iFishIENCi project?
Maybe I can answer this as coordinator of the whole project, because unfortunately we did not discuss today the life cycle assessment aspect. But again, this is included in our life cycle assessment approach, that some of the demonstration experiments and the systems what we are developing will be also analyzed from these aspects. and we will use data directly from the experiments, but also we will use data from the industry and from models for this, and we will evaluate the developments on from this perspective as well.
Danny, I would like to just a small thing about the previous question. So during the video, we saw that our oxygen target is above 6 milligrams per liter. This is not specific for catfish. What I want to say is that we have a strict procedure and about the environmental condition of our species. So we target 6 milligrams per liter, above 6 milligrams per liter for all the species. For catfish, we know that is not doesn't really matter. As Balázs said, oxygen level is not of a concern for when you are rearing up a catfish. So yeah, we know that we can use even a low oxygen content in the water, but it's just because the facility it's about this, let's say, its procedure, it's using that level of oxygen. So it was not a specific requirement for the catfish.
Thank you very much. We have a question regarding the Candida. Any estimation of the feed price with the Candida compound compared to a standard feed?
I think I can answer partially on that, because the feed that we produce for the catfish have been made by let's say experimental facility. So the price is not in line with the, let's say, with the commercial feed. It's just because the amount is lower and the price, of course, is higher. Probably per kilogram, we are estimating like 5-6 times more the actual cost. But this is because the equipment used in the external facility are different from the one used in a commercial facility. The extruder are smaller than the, let's say, the commercial one. So when you produce a diet of 60-70 kilograms per type, it's not the same to produce a ton or 2 tons of a feed. So we can estimate also the cost about the feed production. I don't know about the cost of Candida production. This is something that probably Catherine can say, but as I remember, she already mentioned that the cost is part of the analysis of the project that we are undertaking now. So probably the result will be shown later.
Catherine,
Yes,
would you like to add to that? Sorry.
Yeah, I was just probably repeating a little, but yes, the production for small amounts is not something we can just scale. You know, it doesn't really represent what would be the cost if it was produced on a higher level. But there will be estimates done within the project, and possibly looking into larger productions and how they have what kind of yield have come up from them. But I believe it's for the production of the protein itself, it's quite competitive.
Danny, I would like to answer to the other question because I've seen the chat about using nanobubbles. It's interesting to Clarias and help reduce the oxygen demand. So we know about the nanobubbles. It is a technology that the company is developing also in external project. At the moment, we are not using nanobubbles in-house, but let's say our design and engineering team is working to implement also this one in our facility. So we know about the let's say the positive aspect that you can have using the nanobubbles, but currently we are not using. The oxygen is supplied by a liquid oxygen supplier in the facility. Coaduvate also on the using of ozone to clarify the water and to improve the water quality.
Thanks very much, Gianmarco, for answering that. At the moment, we are now running short on time, though we thank you all for the very interesting questions, and we would welcome any other questions that you do have. So you can send an email to us at any time at info@iFishIENCi.eu. My colleague will put it in the chat there because the spelling is a little bit, as with all Horizon projects, confusing. So please do send us an email. This comes straight to our coordination team and we can answer any questions you might have. We also have future events planned, which if you follow our social medias, you'll be able to see the invites for and register, where we'll discuss other topics in the project, including the results of this and the LCA work and the ongoing achievements of the other parts of the project. So thank you so much for everyone for the interesting questions, and thank you everyone for joining us. We were really glad to have you today. We would be really interested to know your feedback on the event, and if you enjoyed the event, I'd like to put a short survey here in the chat. If you click on the link, this will just take you to a quick question and answer, where we just ask for your feedback on what parts of the event that you enjoyed. You can use the QR code on the screen as well if you prefer to access on your phone, or click on the link in the chat. The survey will be open for the next 2 weeks, so please fill it whenever you have a chance. We'd just like to know what we can do to improve these events for the future, what you'd like to see included in the events, and we'd also love your feedback on whether you learned anything about the sustainability of our project, about the aquaculture 4.0 topic in general, and about the circularity concept of the iFishIENCi. So thank you very much. And we'll also send these to any of the registered participants, the survey link, so you can join as well there. I now pass to Gianmarco and say thank you very much for hosting the event today. It was really, really interesting from the iFishIENCi perspective to see what's going on there in your facility at AquaBioTech. Thank you everyone, the partner, Catherine from NORCE and Balázs from Mate, and also Juliana. Thank you to our coordinator, Tamás, for joining us, and thank you very much for presenting this very interesting research today. Thanks, Gianmarco.
Thanks, Dani. And I would like to take the opportunity to thank everyone for joining the meeting. I hope you enjoy. And as Dani and Tamás said, we're going to repeat the, let's say, this small experiment in the future with a new iFishIENCi trial that will be probably starting in middle of January. We still have some details to decide and to discuss, but we already have an idea of what's coming. Also, I would like to take again the opportunity to ask you to subscribe our Twitter and LinkedIn page. And for the other question, please send an email to me or to all the experts that have been introduced today, and we will be glad to answer your question. Of course, when the experiment will be concluded, we are going to have more details to share. So thank everyone and have a nice day.